Okay, so this is a video for the step support assignment number 11. It was this question about these kind of pseudo-quadratics, we'll call them, and I'll tell you why I'm calling those in a second. So let's start with question number 1 then. So it says use this substitution, so let's just get that substitution down. And now to solve this here, now if I'm going to substitute into here, I'm going to need to know what x is. So if I square both sides here, I'm going to get y squared as x. That's good. So now I can put these things in here. I can say this is y squared, that x there. The root x is clearly just y, and then I leave the rest of it. However, I'm going to times everything by 2 because I don't like fractions. And now I'm going to look for a factorization here, but nothing multiplies to make a 1 that's going to get us high enough to 6, even with this 2. So it feels like I'm just going to have to use the formula. A is 2, B is 6, C is minus 1. Be careful here, you're obviously not given a calculator for steps, so you just have to work through this carefully and properly. Do each thing individually, be careful about the double negatives, add those together. This is 4 times 11, which is root 4 root 11, which is 2 root 11, and then we can cancel a little bit of those 4s, and we end up with this here. Now, this is where we have to be even more careful. You've seen questions like this in A-level maths, but this substitution in particular, you need to be a little bit careful of, because when you take the root of a number, like the root of 9 is 3. It's not plus or minus 3. Even though negative 3 squares to make 9, the root of 9 is defined to be the positive 3. And likewise, root 25 is defined to be positive 5. Any root is just defined to be a positive. So here, because y is a root, y is positive. Now, one of these solutions, minus 3 minus root 11, that's not positive. So I can't have that. I've just got y as the positive solution, right? So if you're using this substitution in particular, you can't have a negative as your new variable. Like if you've got the root of something, that's a positive by definition. So now I've solved for y, but I didn't. The question doesn't have y. The question is asking me for x. So what I do is I say, well, y is root x. So that means root x is all of this. And now I'm going to need to start a new slide because there's more work to do. But what I'm going to do is I'm going to square both sides here. So I'm going to square both sides. Root x squared is obviously x. Square this. Now that's this bracket times itself. Now obviously I can just multiply the denominators, multiply the numerators. So I get a 4 on there. Multiply the numerators out. Just be careful here. Do it properly. Minus 3 times minus 3 is positive 9. Minus 3 root 11. Minus another 3 root 11 makes minus 6 root 11. Plus 11 at the end. And that makes that. You can cancel out one of the 2's in there to make this, I think. And that's my final answer. So yeah, just be really careful of that y being positive thing. If you're making this substitution, this is always positive. And in fact, it says in the question, doesn't it? So you can actually read it. There was kind enough to just give it to you. So the next part of it. Now, if they've given you this substitution, this is a classic thing that STEP always does. If they've given you a substitution to solve what looks like a relatively easy one, and then they get 2 more questions that look a little bit similar, but just a bit more difficult, this is the hint that you just want to find another substitution. So you want to look at this question and think, well, what substitution can I use here, given that I've just thrown one here? Well, here I used root x because there's a root x there. So here, why don't I try using root x plus 2? And remember, y is going to be positive here for the same reason it was before. But anyway, now I can say, well, I'm looking for x. So if I square both sides, I get y squared as x minus 2. Now, when I go into this equation, I'm looking to substitute in something for x. So I'm going to take this equation and take away 2 from both sides. And now I can put this in for that x. And I can also just replace that thing with the original substitution to make plus 10y. And now I can just sort this out, right? And this ends up being nice because it factorizes nicely into this. Because those 2 add up to 10 and they multiply to make minus 24, which means y is minus 12 or y is 2. Except remember, because of this substitution that I made, y is positive. So this doesn't work, only this. That's okay, I can put that into there. I can say 2 is root x plus 2 because I've just found y to be 2. Square both sides, take away 2, and you get x as 2. It might be a great idea if you have time to just double check your answer by putting it into here. So I'm going to take the original thing, going to put my 2 in there. Going to check it works. Root 4 is 2. This does indeed work perfectly, so that's great. So this is the correct answer. Amazing. So we've got that one right. Now part B. Again, find a substitution. So find a suitable substitution that makes this work. Well, the obvious thing to do if I used root x plus 2 for that one is to use y equals root all of this, right? So again, I'm going to square both sides and make a note here, y can only be positive, just like in the first two examples. And now I'm going to go to the original question and I'm going to think, well, how do I most easily replace all of this with y's? Well, that one is clear, right? I just replace all of that with a y because that's what it is. But what about this stuff? Now, if we go back to here and I add 3 to both sides, I get this. And now look how close that setup is to this whole setup. And now it's tempting here for me to divide both sides by 2, but then I'll end up with fractions, so I don't really want to do that. So I'm going to make another pro gamer move. You'll be used to these if you watch these videos. And I'm going to times all of this by 2 to make this. Because that way, these first two terms can just be replaced with those, and I don't have to mess around with any fractions. So I'm going to now replace those two terms with that, y squared plus 3. This is 2, and then all of that is just y, remember, from the original substitution. Minus 18 is 0. Tidy that up, and again, this ends up being a really, or does it end up being nice? Yeah, it does. It ends up being a nice one. So y minus 3, y plus 5 is 0. Okay, great. So now y is 3 or y is minus 5, except remember, y is the root of something, so y must be positive, which means that one goes out the window. Y is 3 is a more interesting case, so let's put that into there. And now let's start a new slide, because again, this is going to take some work. There it is, square both sides to make this. Rearrange to make that. And now all of these are even, so I'm going to divide by 2 just to make the maths a bit easier. Really disappointed about this because this doesn't factorize. Now it's probably quickest for me to complete the square here. Halve this number, take away that number squared, sort that out, add 10 to both sides, square root for plus minus root 10, add 2 to both sides, and I think I get this. And now, I just want you to be careful here, because it seems like we found the right answer. And we might have done, but I just want us to be careful here, because we've done a lot of squaring of both sides. Throughout all of this, we've done a lot of squaring of both sides. And that's usually not a problem. But let's just take this equation here, x is 5. Now, if I square both sides, I obviously get this equation. Now, I hope we can agree that this original equation only had one solution. X is 5. The only thing I can put in here to make this work is 5. But once I've squared both sides, there are actually two things that I could put into this equation to make that work. X is 5 works, or x is minus 5 is. So if you square both sides, you can occasionally end up with phantom solutions. A solution that shouldn't really be there, but is being created because of your squaring. So after we've done all this kind of squaring, you just want to be careful that neither of these are a phantom solution. So go back to your original question, and maybe you just want to put these in there. And I know that's going to be annoying without a calculator, but you're going to want to put these in there and just check that they work. And you can pause the video now and do that. It turns out they actually both do. But it's probably always a good idea to check, certainly if you have time. Now, before I finish this video, I do want to go back to this question here because there is another way to do that. In case you don't take the hint and don't use a substitution, you can do this without one. Just move the x and the 22 to the other side, add 22 to both sides, take away x from both sides, and then square both sides. Now, when I square 10 times this, when you square a product, you just square the things individually. So this is going to be 10 squared, which is 100, times this squared, which is just x plus 2. Obviously, expand this side out, and we make this. And of course, now we can expand this side, and then we can rearrange, and we get this equation, which turns out does factor into this. And if you remember from 5 minutes ago, x equals 2 was a solution to this part A, right? However, we didn't find this solution the first time, and that's because this solution is a phantom solution, right? Like it doesn't actually work. It's only there because of this squaring of both sides. So you do want to be really careful when you do this. So it's probably safer to take the hint and do the substitution, because as long as you remember that that substitution can only be positive if you're doing a square root, you won't end up with a fake solution. The other reason you want to take the hint and do the substitution is because let's look at this one and try and do it without one. Well, again, we can get all the stuff that's not a root to one side. So move the 9 over, move this over and this over, then square both sides, right? Now, if I square this side, it just cancels with the root. If I square this side, I'm going to have to square all 3 terms together. Now, when I expand this out, pause the video, double check my maths, but I think you get this. And now when I rearrange this, just moving these things over, I end up with this. And I've just shuffled it over to make the terms in the order that we usually see them. Now, the problem with this is that you cannot solve this. I mean, I can't solve this. Maybe I could, like after days, but essentially I can't do this, nor can almost anybody else. So this is a problem, right? So if it gives you the hint, do this substitution on this, and then gives you a couple more questions that look kind of similar, do a substitution. And you'll see that with integration as well when you get to integration. But this kind of setup is really, really common, where they give you a nice one to start with, then give you some slightly more difficult ones, and you've got to use the same idea. Take the hint and do the substitution. But yeah, great job if you got that.